God, I hope you don't watch this whole video, but watch parts of it, only the parts that you deem necessary. Okay, so I mean, there are parts that are relatively straightforward. Okay. Do I know how to do this? Okay, here we go. Combine like terms. I know that some of you may not do this, and that's okay. I'll do it. I'll move the like terms next to each other, and notice that I circle the term itself with the sign preceding it, right? Because that. Now, I can move them around as long as I move that whole term with it. Now my like terms are next to each other. There's an invisible 1 there, so it's negative 12 minus 1, which just gives me negative 13a minus 6. Remember, we're subtracting and adding, so we don't add or subtract the exponents here. Likewise, I'll start with the highest exponent, 9v squared. Is going to do absolutely nothing. And then after that, I'm doing alphabetically, so I'm going to do the two p's are next to each other. Okay, look at that. So I get negative 21p minus 8p, and then I'm going to move that positive 14v that's in the front and minus v. So we get, and again, if you focus here, right, this is what we're adding or subtracting. It's negative 21 minus 8 is negative 29p. And 14v minus 1v is just positive 13v. Okay, let's see if I can speed this up. So k squared and k squared, there's a one coefficient of 1 inside in front of each of them. So you know what? I'm just going to cut corners. That's 2k squared. Minus 12k. I'll do it alphabetically. And then there I have negative 8m and negative 21m. Negative 8 and negative 21 is negative 29. Okay. Are there like terms here? Well, let's do... I'm wondering what the order is. Well, let's stick this guy in the front. Negative 12b to the 5th, because that's the highest exponent. And then we're going to do 4a squared b cubed minus 6a squared b cubed. So that's going to give me negative 2a squared b cubed. And last but not least, negative 9a goes all the way to the back. Use the distributive property. Okay. Alright, so again, nothing crazy here. Just give myself some space. Okay. That's negative 28k and negative 32. That was easy. Minus sign here, you can pretend there's a 1 here, right? So negative and negative is going to be positive, so I'm going to get positive m, and the negative is going to give positive again, 9a squared. Or better yet, 9a squared plus m, if you're rewriting it. Doesn't matter, it's fine. Next one, multiply the coefficients with the coefficient. 4 times 5 is 20. X times x cubed, keep the base, add the exponent, so I get x4. Y squared and y to the 4th power gives me y6. And then again, we're going to multiply, we just did this, we're going to multiply that by that. It's a positive times a negative, so it's going to be negative. 4 times 12 is 48. X, no, we multiply with anybody. And the y gives me y to the 5th power. Here, there's an invisible 1 here, so we're, right? So it just comes out the same. Bottom one, negative times a positive is a negative. 3/5 of 15 is 9. And then m3 times m is m to the 4th w. Negative times, so that's that. Negative times a negative is a positive. 3/5 of 20 is 12. All right? Yeah, 12. M cubed, m squared is m5. Pw, put it alphabetically. Last one, negative times a negative is a positive again, and 3/5 of 5 is just 3. M cubed, and then that w and this w gives me w squared. 5/7 times negative 14 is going to be 10. Negative 10m. 5/7 times negative 35, it's going to be negative first of all, and that's going to be 25b. Right, so I divide 35 divided by 7 is 5, and then multiply by 5, get 25b. positive times a negative for the last one is going to be a negative, and then this one, 7 divided by 7, right? It's just 1, and 1 times 5 gives me 5g. Okay, you can rearrange that alphabetically if you like. That's okay. What is this? You distribute product combine like terms. Ugh. Who writes these problems? Yes, it was me. Okay, let's go. Okay. We get 6k, so again, distributive property, I get 6k to the second power minus 12km plus 12 minus 8k squared. So, combine like terms, I have a 6k squared here and a minus 8k squared, so that gives me negative 2k squared. And then the rest, they're not like terms at all, so I just write them down. Here I get 5 times 8 is 40, and 8 to the 7th. And then the second one's going to be negative, and 60, 8 to the 6th. Minus 6, 8, 7, minus 7, 8. They're combined like terms? Yes, there is. This guy here and this guy here. Careful of the sign. So 40a7 minus 6a7 is 34a7. And then this combines with nobody, so it's minus 60a6 minus 7a. Okay. 2p to the 4th power, right? Multiply these two. And then it's minus 2p to the 3rd w minus 5. And then this is what's doing the distributive property. So it's negative 3 times p squared times p is going to be negative 3p to the 3rd power. And then negative times negative is a positive, and it's going to be positive 3p squared w3. Ugh. Are there like terms here? Doesn't seem so. So I just, again, let's rewrite that. So I would put that's gone. Alphabetically, it would be, and then that one, then would be this minus 3p cubed. And then it's going to be this one minus 2p cubed w, and then this guy plus 3p squared w 3rd power minus 5. If you don't rewrite it, it's okay. I'm just writing it down. 12 minus 6h, the distributive property happens between the negative 4. So it's got negative 4h, negative 4, negative 7 is positive 28 plus 9h. Combine like terms, yeah, there are some terms here. Negative 4b goes up to the front. And then we have 6h and 9h, negative 6h, I'm sorry, positive 9h, and that's going to be plus 3h. And then we have a positive 12 here and a positive 28, and that's just plus something, 40. 19k plus 14x plus 56k. Minus 9, that's not the distributive property. And then there's an invisible 1 over here. And by now you know that if it's a minus sign, everybody inside comes out opposite. So that's going to be negative k, negative 15. Combine like terms. This guy, the 56k, and the minus k. So 19k, so I have 19 plus 56. They're both positive. That's going to be 75 minus the 1 here, so that's going to be 74k. Then it's going to be the 14x plus 14x by itself. And then we're going to combine negative 9 and negative 15. It's going to give me negative 4. Okay. Here, instead of a bonus word, how about this? Figure out how many mistakes I make. Well, then you would have to watch the whole video. So, negative times a negative is a positive, so that's just 1/6m. Negative times a negative is a positive again, and 1/6 of 42 is just 7. Negative times a negative is a positive again, and then 1/6 of 18 is just 3, but don't forget the k. Minus 23, minus 17m. Like terms, well, let's start with alphabetical. So I'm going to have 3k, I'm going to put it over here first, and then I'm going to combine the 1/6m and minus 17m, and that's just going to be negative 16 and 5/6m. And then positive 7 and negative 23 is going to be negative 16. should have chosen some happier music. Yikes. Right, we're moving. Oof, one more. Okay, so I got a couple of emails of the sequences. There, I think a couple of them that I have probably copied wrong. Let's do this one on the right side. So that's going to be, again, there's a minus sign. Again, if you want to imagine there's a 1, that's okay. So everybody's going to come out the opposite. 4m becomes negative 4m. 9k is going to be plus 9k. This one, because it's a plus sign, everybody comes out exactly the same. Positive 7k minus m. Combine like terms. Let's do the k's first because they're next to each other. Well, 9k and 7k is just 16k. And then negative 4m and negative m is negative 5m. Over here, negative 4 is just hanging out there. Negative times a positive is a negative. 1/3 of 45 is 15. And then m times m is m squared. Negative times a negative again is a positive. And 1/3 of 12 is 4. And don't forget it's km, right? Because we're multiplying. Then negative times a negative is a positive, and 2/5 of 30 is 12 m. Then negative times a positive is going to be a negative, and 2/5 of 15 is going to be 6 km. Okay, let's see. Let's do the km first. 4 km and minus 6 km is negative 2 km. Oh, I should have done that first. Okay, you know what? This guy here, highest power, goes in the front. There's nobody to combine with. And then, lastly, I combine negative 4m and positive 12m, and I get positive 8m. So far, I think I haven't made any mistakes so far. Now, as far as the patterns go, I will probably give you, like, visual, like, with pictures. Which that definitely gives you then an option of actually of either doing, looking for patterns, or you can do it finding the first difference, second difference, etc. Okay. Let's see if I can do this. First, let's see, that's a 3, that's a 3, that's a 3, that's a 3. That's linear. So that's going to be a 3n sequence. What does the 3n sequence look like? Well, 3 times table, right? 3, 6, 9, 12, 15, right? Now, we can subtract. So I know my sequence. So my sequence, we can write my rule, is going to be 3n. Now, do I have to make any adjustments to my 3n sequence to get 6, 9, 12, 15? Yeah, I do. And what's that adjustment? Well, if you subtract, you get it, right? 6 minus 3 is 3. 12 minus 6, 9 minus 6 is 3. 12 minus 9 is 3. 3 and 3. So it is 3n plus 3. And you can plug it in, right? For like this one, 18 is the 5th term of that sequence. So if I plug in 5 over here, do I get 18? 3 times 5 is 15 plus 3 is 18. Yeah, seems to work. Let's see this one. First difference again. That's looks like a 5 plus 5 plus 5 plus 5. So it's a constant, right? Plus 5. Change here. So therefore, it's a linear again. So it's a 5, right? So it's 5n sequence here. 5n sequence goes 5, 10, 15, 20, 25, etc. So I know my rule, part of my rule is 5n. And now I have to make an adjustment to my 5n sequence because I don't want 5, 10, 15, 20, 25. I want 1, 6, 11, 16, 20. So again, in this case, if you subtract 1 minus 5 is negative 4. 6 minus 10 is negative 4, and so forth, and so forth. So what adjustment do I have to make to 5n? I have to subtract 4. Well, let's see if it works. Let's pick the third one. The third number of my sequence is 11. So if I put 3 over here, I get 5 times 3 minus 4. 5 times 3 is 15 minus 4, 11. I would definitely check a couple of numbers, okay, just to make sure that the sequence is correct. So wondering which one is the incorrect one. I should check my email. All right, let's just do this. Let's go. First difference. Oops. 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 6 to 7 is, I don't know, 11. 34 to 17 to 34 is plus 17. 57 and 34 is 23. And then 57 to 86 is going to be 29. So definitely not linear because it's constant. It's not a same change here, right? So take the second difference, see if that works. 6, 6, 6, definitely quadratic. So take that 6, halve it, we get 3. So sorry, 3n squared. So what does the 3n squared sequence look like? Well, let's substitute n, right? n, 1 to the second power is 1, times 3 is 3. 2 to the second power is 4, times 3 is 12. 3 to the second power is 9, times 3 is 27. 4 to the second power is 16. 16 times 3 is 48. And then 5 to the second power is something, 25, and that gives me 75. So, right, my rule right so far, I know that it's 3n squared and something else. Let's subtract. 6 minus 3 is 3. 17 minus 12 is, I don't know, 5. I'm thinking this is 7, 9, 11. Okay, so again, we start all over again. Find the first difference. This is a 2, this is a 2, this is a 2, this is a 2. So there's a linear sequence inside this sequence inside as well. So it's going to be 2n. What does the 2n sequence look like? It's 2, 4, 6, 8, 10, etc. Do I have to make any adjustments to this sequence to get 3, 5, 7? Yeah, I do. So what's 3 minus 2 is positive 1, 5 minus 4 is positive 1, it's just 1 and 1 and 1. So it's going to be this plus 2n, and the little adjustment that I make to my 2n sequence is to add 1. Let's pick a number. Let's pick, I don't know, let's 5. So if the fifth number of my sequence is 86, so if I plug in 5 over here, and 5 over here, I should get 86. 3 to the fifth power, 5 to the second power is 25, times 3 is 75, plus 10, plus 1, and that's definitely 86. So it looks like I'm right. If you have time, check two numbers. Okay. You know what? Give me a second. 5 for. Let me just check the email that I got from you guys stating me, telling me which ones that I. Here we go. So it's the one that. No, not that one. Hang on a second. No, it's from what in the world? Hang on a second, guys. Five, 9. So okay, so that one, the corner, the first. Okay, so that apparently I just got Sophia 2, 5, 9. All right, so it's this one that's not making any sense. Okay, so meanwhile, where was I? Here. Those are the ones that we can. 7 to 16 is 9. First difference. 16 to 19 is 13. 46, 29, 46 is, no idea, 17. And then it looks like 21. Yeah. Definitely not linear. Second difference, we get 4, 4, and 4. Okay. So we know it's quadratic, but it's going to be half of 4, so it's 2. A 2n squared. So once it's going to be 1 squared times 2, which is 2. 4 times 2, which is 8. 9 times 2, which is 18. Right? And then 16 times 2, which is 32. Do I need one more? 25 times 2 is 50. So that's what that. Let's subtract. Now 7 minus 2 is 5. 16 minus 8 is, I don't know, 8. 29 minus 18 is 11. 46, that's 14, and then 17. Okay. So far I know that my sequence is going to be made of 2n squared. I'm going to take the first difference again. And it's 3, 3, 3, 3. So there's a linear in there. 3n sequence, right? Because it's going by 3s. 3n sequence is 3, 6, 9, 12, 15. And do we need to make an adjustment to that sequence to get to 5, 8, 11, 14, 17? Yes, we do. And that adjustment is going to be to add 2. Well, and we can also find that by subtracting 5 minus 3, 8 minus 6, 11 minus 9, blah, blah, blah. So there's the plus 2 at the end. Let's just double check. Let's pick the third one. So the third one is 29. So if I plug in 3 here and 3 here, sorry, I should get a 29. So let's try that. 2 times 3 to the second power plus 3 times 3 plus 2. 3 to the second power is 9 times 2 is 18. 18 plus 9 plus 2. And that definitely gives me 29. So it looks like I'm good. Okay. First, looks like it's a 5, and then a 7, and then a 9, and then that's 11. Wow, that's nice. Second difference is 2, 2, and 2. So definitely a quadratic here, but just n squared. N squared is just 1, 4, 9, 16, 25. So that's easy. Let's subtract. 3 minus 1 is 2. 8 minus 4 is 4. 50 minus 9 is 6. 8 and 10. Okay, so I took the quadratic out of this original sequence, and now I'm left with this. I'm going to take the first difference again. And you can tell it's easy. That's a 2, that's a 2, that's a 2, and that's a 2. So that means there's a 2n sequence in there, and a 2n sequence is 2, 4, 6, 8, 10. So this one is nice because I don't have to make any adjustments to my 2n sequence to get to 2, right? So it's just going to be, well, if you subtract, it's 0, 0, 0. So it's going to be actually, my rule is 2n squared plus what? 2n. Let's verify. Let's pick the first one. Let's be. So if I plug in 1 over here, I should get 3. So 1 squared plus 2 times 1. That's 1 squared is 1, 2 times 1 is 2, and I get 3. This one here we're not going to do. I'll let everybody know tomorrow. Okay. Alright, so this doesn't, no idea how long the video is so far. Factor, what's in common here? So we gotta take the greatest common, using the greatest common factor. Alright, so let me set this up. I can go ahead and do that if you want. So, what do they have in common? So, let me, before I do that. Trying to figure out if I can do this. I'll do this for this problem. So that's, I'm gonna just expand that. So a cubed is a times a times a, and b 4 times. And then 18 is a times a times a 4 times, and b 3 times. So I gotta take what's in common, right? That's gonna be my factor outside. So 21, 36, 18. What's the greatest common factor? Is it 3? Ugh, really? All right, 3 is the greatest common factor between 21, 36, and 18. Now, as far as A's are concerned, how many A's do they share? Do they have in common? They have, each of those has 2, right? There's 2 over here, there's 2 over here, and there's 2. So I'm going to take that and put it outside. I'm going to write a squared. And you know what? I'm going to cross that out. And then do they share any B's? Yeah, they share. They lead, right? They have 1 B each that they share. So B 1b, and 1b. That's my factor outside. So 3 times what's 21? It's 7. Do I have any variables to put in here? No, I don't, because they have all been used up if you look at it. And then if I just double check, 3 times 7 is 21, and then a squared b tag along, and I get this first term. So I'm good. Minus 3 times what's 36? It's 12. How many a's haven't been used here? It's a, 1a, right? There's one right here, and 3 b's here, so that'd be b cubed. Now, you can confirm this by, again, doing the distributive property. 3 times 12 is 36. A squared times a gives me a cubed over here, and b times b cubed gives me b to the 4th power. So that one also checks. And lastly, 3 times what is 18 is 3 times 6. I have 2a squared, 2a, so that's a squared, and 2b, so that's b squared. So does that work out? So 3 times 6 is 18, check. A squared times a squared is a to the 4th, check. B times b squared is b cubed, checked. So this is the equivalent expression. Likewise here, now again, I'm not going to do this one with, by expanding. You can do it. Let's see if I can do this without expanding. So I know the greatest common factor is 4 as far as number-wise. They each share, well, let's go alphabetically. X, there's no x in the middle term, so they don't share x's. What about y's? They do share y, so the greatest amount that they share is 1y. So I'm going to put y over here. Do they all share z's? No, they don't share z's. So that's what they share. Now, well, 4y times what will give me 12x cubed y squared z? Well, 4 times 3 is 12, and then I'm going to have to add the x cubed. 1y, because y times y gives me y squared, and I have to add the z. Minus 4 times 5, and then I need to have y cubed here, so y times y squared will give me the y cubed, and then I'm going to add the, and I'm going to add the z. 4 times what is 4? We don't have to write 1, right? And then I need to add the x squared, and do I need to add a y? No. 4 times the invisible 1 here is 4, and then x squared is over here, and then y is over there. Right? So this times this gives me this. Okay. Yeah, that's pretty much it. Oh no, there's more. Okay, what is this? Am I doing the same thing? Okay, so greatest common factor is 7. No variables are shared, so I get negative 5m minus 2k minus n. And then the beauty about this is that you can automatically check and make sure you get negative 35m minus 14k minus 7a. So there are the equivalent expressions. So here, 9, 12, 6, and 30. So 3 is the greatest common factor. Do they all share the letter m? Yeah, that's the only thing that they share. So 3m times 3a gives me this, right? 3 times 3 is 3, and then am. Plus 3 times 4 is 12, and then I have to add the p. So 3 times 4 is 12, mp. Check. 3 times 2 is 6, and then m tags along, and then I just add the x. 3 times 2 is 6, and mx is mx. Check. And lastly, 3 times 10 is 30, and then do I add an m? No. So it's just 10 there. So that checks out. So far, I think I'm doing okay with no errors. Now I'll multiply binomials. Okay. So this is just a distributive property twice. Right. So not too sure. So 2x times x is 2x squared. 2x times that 6 gives me 12x positive. Negative 5x, negative 5 times x is negative 5x. And negative 5 times 6 is just negative 30. Can I combine in like terms? Yeah. 2x squared, the minus 5x, and then I'm going to combine the positive 12 and the minus 30 gives me negative 18. 4a times 2k is 8ak. 4a times negative, it's going to be 8. It's going to be negative 32a. Negative 5 and positive 2 is going to be negative 10k. And then negative 5 and negative 8 is going to be positive 40. Like terms? Really? No like terms? Huh. Am I missing something? No. Okay. Next one. X cubed. Let me change colors. X cubed 2x is going to be 2x to the 4th power, right? And then x cubed and the y here is going to be just x cubed y squared. Then it's 3y and 2x and then minus 6xy. And then the negative 3y and the negative y squared is going to be positive 3y to the cubed. Like terms? Nope. Wow. Okay. 2m and negative 3m is negative 6m to the 2nd power. 2m and that w in the corner is going to be positive times a negative, negative 2mw. And then here, second term, second factor here, negative 4 and negative 3 is positive 12. M, and I'm just putting alphabetically, W3. And negative 4 W cubed minus, times negative W is just positive 4 W to the 4th power. Like terms? No. And you can rearrange this to write it in order. And I'll do that. Plus 12mw cubed minus 6m squared minus 2mw. And that's that. All right. Okay, I'm moving. So far it looks okay. So multiply the coefficients. 2 times 2 is 4. M squared and n cubed. Keep the base. Add the exponent. 4 times 2 is 8. So here, there's two ways you can. Well, there's several ways you can do this. 4 times 2 is 8. N4 and n negative. Let me pull that to the side for a second. Keep the base, right? Multiply and add the exponents. What 4 plus negative 3 is just n to the 1st part. And that's my answer, 8n. Now, those of you who want to do it this way, it's also okay. So let me erase this for a second. You're like, I want to change that negative exponent to a fraction. That's okay, to the reciprocal, right, with a positive exponent. So we get 4n4 times 2, right? So that stays in the numerator. That stays in the numerator. The 2 stays in the numerator. But n to the 3rd goes down. Let's continue. Well, I can now multiply these two. I could have done that earlier. 4 times 2 is 8. And now I have n4 and n3. Well, n4 means n times n times n 4 times. And n3 at the bottom is n times n times m. So if you cross out, where am I going to have leftover n's? In the numerator. And you get the same answer. Your choice. Here, you know what? Let me... don't matter. 4, a to the 3rd, b to the 2nd. I'm going to actually throw the 3 to the bottom, right? Oh, sorry. Sorry, let me start again. 4 times 3, the coefficients, that's nice and easy. It's just 12. A to the 3rd stays, b to the 2nd stays, right? So that's taken care of. 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 A to the negative 4th, over here. B to the negative 3rd, goes down. Now I'm ready to simplify. So 12, nothing's going to happen to it. A3, A4, I'm going to have 1a left over at the bottom, right? After they cross out each other. And then b squared and b cubed, I'm going to have 1b at the bottom. So final answer, a little bit prettier than that, is this. 12 over ab. This is going to be the 4 multiplied by everyone inside, right? So we get 3 to the 4th power. And then k to the 16th powers. We can rewrite this as, what is that? 3 times 3 is 9, times 3 is 27, 81, k16. Negative 1 gets, so again, you know, actually, I'm going to do it this twice, two different ways. So let's do it this way, where I multiply that by everybody inside, and I get 2 to the negative 1st power, x to the negative 4th, and y to the 3rd. Now, the y to the 3rd is going to stay in the numerator. 2 to the first power, negative first power, is going to come down, and x to the negative fourth power is also come down. So that's your final answer. The other way, and nobody, I guess, nobody raised their hand when I ask if anybody, is to automatically go like this. x4 wider than negative third, and then that exponent of negative 1 becomes positive 1. Now, if I now multiply that positive 1 times everybody, I'm going to get 1 over, and 1 times, right, so that's just 2, x to the 4, y to the negative third. Then what ends up happening is that I have to throw that y to the negative third up to the numerator. That goes up, and everybody else stays down. Notice that it is the same way. It's a matter of whatever your comfort level is. Okay, here. Okay, so x to the negative first power, I'm going to throw that, right? That becomes, so the 4 stays, x to the fourth power. And this fell over here. I'm going to put him over here. And then don't forget to put him over there. Simplify that a little bit better than that, and we get 4x to the fifth. Okay, so get some room here. Alright, so let's see if I can. Well, the 2/3 stay. I'm going to cross them out because I don't want to see them. X to the fourth and x to the second power. Well, there's 4 x's on the top, 2 x's at the bottom. So if I cross, I have x squared on the top left over. So that's done. Y to the negative 4. Let's throw that to the bottom. Y to the negative third. Y to the negative fourth goes to the denominator. Y to the negative third goes up. Z to the negative 3 comes down. And z to the fourth also just stays down. Doesn't even move. I can simplify this a little bit better than this. And I'm getting 2/3, don't do anything. The x squared doesn't do anything. Y3, Y4, I can simplify, and I just have y at the bottom. And Z3 times z to the fourth power is just z to the seventh power. Okay. Pay attention to this problem, because this might be where you will lose a point. This is to the fifth power. So if you think about this, all right, let me expand it out. It's negative 2x4, negative 2x4, negative 2x4, negative 2x4, negative 2x4, right? So x to the, well, let's do the exponent for the variable for x to the fourth power is x to the fourth, and you have 1, 2, 3, 4, just being multiplied, right? So it's x to the fourth times x to the fourth times x to the fourth. If you keep the base and you add the exponent, you get 20. And that you could have gotten just from multiplying 4 times 5. So you're okay there. Now, the reason I'm doing this is to show you what the sign is going to be here. We're multiplying negative 2, so focus on the negative. Focus on this right here. That times that times that times that times that. It's a negative times a negative times a negative times a negative times a negative. So there's an odd number of negatives. So my product here is going to be negative something. In this case, 2, 4, 8, 16, negative 32. Okay? You gotta be really, really careful here. Okay? Now, the other one over here, it's the same exact number, negative 2x4, and we're gonna do this 6 times. 4, 5, 6. So it's negative 2 times negative 2 times negative 2 6 times, so it's going to be positive 2, 4, 8, 16, 32, 64. In this case, 64 positive. The x, keep the base, add the exponents. You got 4, 8, 12, 16, 20, 24, or just 6 times 24. 6 times 4 is 24. Okay, so now if you don't want, obviously nobody here is going to be doing that. So over here, when you do that, there's a invisible 1 over here, right? So it's negative 2 to the 6th power and x to the 24th power. But in this case here, right, that 6 applies because this whole thing, that 6 is taking negative 2, and even that, right, negative 2 multiplied by itself. So that has to come out positive. And then I guess if you expand it, you'll see a little bit clearer why it's positive. Okay. Be careful with that. Is that it? 2 more problems? I can do this. Ugh, choices. Like I said, I don't want you guys to like just do just because I've shown you this. And if it's easier for you, great. If you like to, again, right away get rid of that negative by switching the numerator and denominator, you can do that. Okay. So we're going to get this, and I'm going to do negative 2 to the 3rd power, negative 3rd power, a to the negative 12, b to the 6, c to the negative 3rd. It's going to be 4 to the negative 3rd, a to the 15 positive, b to the negative 15, and c to the negative 6, if you did it that way. Okay, so let's see if we can simplify this anyway. Negative 2 times negative 2 times negative 2 is just 8. 4 to the negative, so that's gone. 4 to the negative 3rd power, I'm going to drag that upstairs. Actually, you know what? Let me do it the numerator first. So negative 2 times negative 2 times negative 2 is negative 8. A to the negative 12 power, I'm going to drag it down here. B to the 6 stays up. C to the negative 3rd comes down. I took care of my numerator. My denominator, 4 to the negative 3rd power, it's 4 times 4 times 4. And again, it's going to be, sorry, what I meant, I'm going to throw him upstairs. Let me throw him upstairs first. A to the 15 is going to stay. B to 15 is going to, B negative 15 is going to go up. So we change that to positive exponent. C to the negative 6 goes up. Now, next up, let's see if I can clean this even better. Let's see, 4 to, okay, so at the bottom, let's see if I can, well, negative 8, so let's do the coefficients. 4 to the 3rd power is 64. 64 times 8 is going to be 2, carry 3, 48, 512. No. 32 goes 3, 48, yeah, 512. So I'm going to get negative 512 as far as the coefficients. This negative 8 and that 4 to the 3rd power. Then I have left over B6, so let me cross these two out. B6 and B15 is B21. And then C6. At the bottom, I have A12 and A15, which I can combine and write A27, and then I write C over 3. Is there anything I can simplify? Well, yeah, there's one more. I can simplify the C's. So it's still negative 512 B times B to the 21st power over 8 over to the 27th power, and then C6 and C3 is just C3 on the top, I think. Okay. This one, I don't know why I can't see the bottom part. Give me 1 second. Hopefully I have a printout. And I do. Alright. Okay, so I'm definitely going to need a little more space for this question. So I'm actually going to rewrite the whole question. Yikes. X squared, y to the negative second, z to the 3rd, over 2, over 2, x to the negative 2, y to the 4th, all that to the 4th power, times 4 cubed, y to the 5th power, over z, negative 4th, all that to the negative 2 power. Alright, so let's do the first parentheses first. Let's use the expanded row. So I'm going to get x to the 8, y to the negative 8 and z to the 12. At the bottom, I'm going to get 2 to the 4th power, x to the negative 8th power, and y to the 16th. And then over here, I'm going to get, this all being multiplied, right? 4. So I got cut off. My battery died, actually. All right. Where was I? Hang on. Oh, let me do the whole thing again. So let's see. So that's where I was. Okay, x to the 4th, everything looks good. Second parentheses, I have 4, and then 3 times negative 2 is negative 6, y to the negative 10. At the bottom, z to the negative 4 is z to the positive 8. Now I just gotta rearrange things and make... Alright, so I'm going to continue on this side over here. Okay? So let me go to the top. Okay, x to the 8 stays, y to the negative 8 goes down, z to the 12 stays, 4 to the negative 6, so that's done, that's done, that's done. 4 to the negative 6 comes down, y to the negative 10 comes down, sorry, but comes down as a positive exponent, sorry. So that's done, that's done. Let's do 2 to the 4th, 2 to the 4th stays down, x to the negative 8 goes up, y to the 16 stays down, and z to the 8 stays down. Now I have to clean up this mess. Be sure. X to the 8, so x to the 8 and x to the 8, they're same base. Add the exponent, gives me x to the 16, and then z12. That's easier. At the bottom, I have y to the 8th, y to the 10th, and y to the 26, and that's going to give me y to the something, 34. And then I have z to the 8. Okay, so that's, I'm just going to put it over here. And then I have 4 to the 6th power and 2 to the 4th power, which I'm going to use a calculator. So we learned that 4 to the 6th power is the same. No, really? 4 times 4 times 4, 3, 4, 5, 6 equals 4,096. Yikes. So 4 to the 6th power is 4,096. And then 2 to the 4th power is 2, 4, 8, 16, and that's 16. So I have to multiply 4 to the 6th power and 2 to the 4th power. So this guy and this guy I have to multiply. Well, you have a calculator, so it's not going to be. So that's going to be 6,555.36. 65,536. Is there anything left for me to do? Yes, there is, because that Z12 and Z8 can be also simplified. So I'm going to write one more line cleaner. X to the 16, that stays. Y to the 34, that stays. 65,536 stays. And then Z to the 12 and Z to the 8, it just becomes Z to the 4th, but on top. So that's my final answer. Let me try if I can write the Y a little bit cleaner. So the Y is to the 34th power. Okay, so let me just take a look and see 4, 6, yeah, that goes down to the 4th power, which is, yeah, that's, okay, yeah. So that's my final answer. Okay,